This week we're going to focus on solving quadratics using factoring. When it comes to solving quadratics using factoring, the first thing we need to talk about is what's called the zero product property. This says that a product of two factors is zero if and only if at least one of the factors is zero. So if we had something such as a times b equals 0, the only way that that's going to work is either a has to equal 0 or b has to equal 0. The only way to get 0 through multiplication is to multiply by 0 itself. We kind of saw this with exponential functions when we would approach 0 but never actually get to 0 because there's no way to get to 0 without having 0 as a factor. Now, this is going to allow us to solve quadratic functions because we're going to be looking for when the whole function is at 0 or when y is 0. If you think about having two binomials, let's say x plus a or x plus b here, if that's equal to 0, then we would know that either this first set is equal to 0 or this second factor is equal to 0. So we're going to use this zero product property to help us determine the values of x that make the equation zero out. When we talk about solving quadratic equations, we are talking about finding the x-intercepts, or when the whole function is at 0, so when y is 0. However, they don't always ask you for the x-intercepts. A lot of times they will ask you for the zeros, meaning what are the values that create a 0 for the whole equation. They sometimes will also ask you for roots, solutions, or x-intercepts. So any of those items mean they are asking you to find when the equation is set equal to 0 or when y is equal to 0. When we go to solve, we're going to have one of these three possibilities. Now, most common is that we'll have two solutions. That means that our quadratic graph crosses the x-axis twice, and there are two values of x that would make the equation equal 0. Another option is for us to have just one solution. So that means that it only touches the x-axis at the vertex, and so there's only one value of x that will make it equal 0. And then the third option, which we will not really see while we're doing factoring, is for it to have no real solutions. So this is something that we'll have to use a different form to solve because it wouldn't be an equation that would factor. And so you will see those coming up in the next couple of weeks. So there are three steps that you really need to focus on when you're solving by factoring. The first is to make sure that your equation is actually set equal to 0. And if it is not, then you would want to force it to be set equal to 0. The second step, is to factor the quadratic into the product of two binomials. So we're going to factor it, get our two binomials that were used to multiply to get that quadratic in the first place. And then the third step would be to set each binomial equal to 0, because the only way for the whole thing to equal 0 is for either the first binomial or the second binomial to equal 0. And then by solving each binomial, we can find the 2 or 1, whatever the case may be, 0. So if we're looking here at x squared minus 21 equals 4x, this equation is not set equal to 0. What I would want to do is I would want to move 4x from the right side to the left side with the other two terms. So I can subtract 4x here, which would equal 0, anything minus itself. And I would need to do the same thing over here. There's no other x's, so there's nothing to combine with, so it just will stay. So we'll have x squared minus 4x minus 21. At this point, I would want to see if there's a greatest common factor I could bring out. X squared is already as simple as we can make it, so there's no greatest common factor. So I would go to factoring it into the two binomials. So we have our x squared and our negative 21. So that gives us negative 21x squared. Factors of negative 21x squared that add to negative 4x. So we could have negative 21x and 1x, but that's not going to equal 4x. It's going to be negative 19x. We could have negative 7x and 3x, which would be negative 4x. So that's going to be the factors we need. I'm sure a lot of you are not needing to go to the side anymore to find these factors. You could probably do them in your head, and that's fine. Then we would go and say, well, what does the first row have in common? So between x squared and negative x, or negative 7x, we have an x. And between 3x and negative 21, we have a 3. And then x times x would give us x squared, or 3 times x would give us 3x. And x times negative 7 would give us negative 7x, or 3 times negative 7 would be negative 21. So our factored form is going to be x minus 7 times x plus 3 has to equal 0. Well, the only way this is going to work is for either x minus 7 to be 0 or x plus 3 to be 0. That way we're going to be multiplying by a 0 in one of the two. So we would say, well, it's either going to be x minus 7 has to equal 0 or x plus 3 equals 0. If it's x minus 7, sorry, then we would add 7, and our value of x that makes that binomial 0 would be 7. On the other, we would subtract the 3, and so the value of x that makes this one equal 0 is negative 3. It's also in intercept form, if you think about that from last week. So we have minus 7, that means the 0 was at 7. And we have plus 3, which means it was minus negative 3, so the 0 was at negative 3. So hopefully this kind of shows you why we are subtracting them in the format of intercept form, because we have to do the inverse to get it to the other side to find out what value of x actually makes it 0. So this quadratic would cross the x-axis at 7 and negative 3. Those are our two solutions. On this problem, we have 5x squared minus 33x minus 14 equals 0. It's already said equal to 0, so we don't have to make that happen. And there's no common factors between 5, 33, and 14. So we are going to have to take this and factor it as it is. So if we do 5x squared and negative 14, then that's going to be 70x squared. So negative 70x squared is what we're looking to factor for our middle term to add up to negative 33x. So, negative 35x and 2x would make negative 70x and add to negative 33. So I know we're going to use negative 35x and positive 2x. On the first row, the greatest common factor we have between those is actually 5x. And on the second row, the greatest common factor is a positive 2. 5x times x would give you x squared, and 2 times x would give you 2x. So on the second part, 5x times negative 7 would give you negative 35. That's very poor penmanship, I'm sorry. And 2 times negative 7 would give you negative 14. So our binomial parts are 5x plus 2 and x minus 7. Those together should equal 0. That means that either of those two can be 0. So if the 5x plus 2 is the one that equals 0, we could solve that. And if the x minus 7 equals 0, then we could solve that one. For the 5x plus 2, we would subtract 2. 5x equals negative 2, and then divide by 5. So 1, 0 would be at negative 2 fifths. On the second binomial, if we add 7, that one would be at 7. So we could say the two zeros are x equals negative 2 fifths or x equals 7. Sometimes they'll write these as actual zeros or as ordered pairs, and so you may see it as negative 2 fifths, 0, and 7, 0. That's also an acceptable answer. I think at this point you could probably try one on your own. If I was going, this one's already set equal to 0, so I don't have to worry about that. This is going to be a unique situation because there is no middle term. I could represent it as 0x. We've seen this before. So I need something where I have x squared and negative 81, and the middle cancels out completely. Well, the only way to get negative 81x squared and cancel out is for you to use the same number, opposite signs. So this would be 9x and negative 9x. That would make 0x, so we won't see a middle term. On the first row, the greatest common factor would be x. And on the second row, the greatest common factor would be negative 9. And then we would have x times x, or negative 9 times x, and then x times positive 9, or negative 9 times positive 9. So the binomial factorization here is x plus 9 times x minus 9 has to equal 0. And then it's either going to be one of the two. So x plus 9 could equal 0, or x minus 9 equals 0. This one would be minus 9. So x equals negative 9, and this would be plus 9. So x equals 9. So our two zeros are negative 9 and 9. We could say x equals on both of those. Or we could write them as ordered pairs, negative 9, 0, and 9, 0. Okay, this one is not set equal to 0, but I do think you could still try it on your own. You can create the 0 by subtracting 8x on both sides. So we would have 4x squared minus 8x plus 4. And then you could factor from here, or you should recognize that all of these are divisible by 4, and you can factor the 4 out first. So that would mean it's 4 times x squared minus 2x plus 1 equals 0. This would make the factorization much easier, and it would eliminate having multiple possibilities for the factoring. So we have x squared and positive 1. That means we're trying to find factors of 1x squared, but it has to be a negative. The only way that's going to happen is for both of these boxes to be negative. So it's going to have to be negative 1x and negative 1x. Then if we factor from the first row, they have an x in common, and the second row has a 1 in common. X times x is x squared, but x times 1 is not negative 1x. And that's because we're trying to force a negative in the middle from two positives. So this is going to have to be a negative 1. And then x times negative 1 here would make negative 1x, and negative 1 times negative 1 would make positive 1. So our factored form would be 4 times x minus 1 squared, really, because they're the same thing. Now, is there a way for 4 to equal 0? Because that is being multiplied, and that will never happen. So the only option here is for x minus 1 to equal 0. So if I add the 1, I'm going to get x equals 1. So this is a situation where there's only one solution, and that solution is 1 or 1, 0 if you write it as an ordered pair. It only has the vertex on the x-axis. So I'm going to include a real-life scenario here because it's going to show up on your assignment, and it's going to be a little bit tricky if you haven't seen it. So it says the area of a rectangular patio is 168 square feet. The length of the patio is x minus 5, and the width of the patio is x plus 8, and you need to determine the length and width of the patio in feet. Well, you should know from lower grades that area of a rectangle is length times width. So if I know area is length times width, then I know that 168 is area, length is x minus 5, and width is x plus 8. And then I could simplify this by going ahead and performing the multiplication between x minus 5 and x plus 8. You may need to come down and do your multiplication with a box, or you may be confident enough in your ability to distribute the x and distribute the negative 5 that you don't need the box anymore. Either way is fine. So this would be x squared and 8x, negative 5x, and negative 40. So we would have 168 equals x squared plus 3x when you combine 8x and negative 5x, and then minus 40. I'm going to set it equal to 0 so I can solve it using quadratics. So if I subtract 168, I now have 0 equals x squared plus 3x minus 208. And there's no way to simplify this one, so we're going to have to find factors of 208 that make a 3x. So let's switch over to factoring here. I know I have x squared and negative 208. I need factors of negative 208x squared that will produce a positive 3x. So you could try 1 and 208, 2 and 104. This isn't divisible by 3. It could be 4 and 52. There's a lot of different options here, but I know it's going to be negative 13x and positive 16x. And if you're not just sure of that one, then you could just try all of them through your factors. There's also a way that you can do negative 208 divided by x, like in a graphing calculator on y equals, and pull up a table, and it will give you perfect pairs that make that work. But trial and error is probably your best bet here. So on the first row, I have x in common, and on the second row, I have 16 in common. And then this would be x times x and x times 16, and then negative 13 times 16 as well. So our factorization is x minus 13 and x plus 16 equals 0. Now here we're going to get x minus 13 equals 0 or x plus 16 equals 0. So the two zeros would be 13 and negative 16. In this scenario, if x were 13 and I use that for length and width, I would end up with positive numbers. So 13 minus 5 is positive, 13 plus 8 is positive. But if I use negative 16 minus 5 is negative, negative 16 plus 8 is negative, and having negative dimensions on a rectangle does not make sense. So although this is a solution to the quadratic, it is not a reasonable solution to the actual problem. So I want to go with my positive solution. And then I'm going to take my length, which was x minus 5, and I want to replace x with 13. So 13 minus 5 tells me that my length is 8 feet. I'll do the same thing for width. So my width is x plus 8. That's 13 plus 8, or my width is 21 feet. So this patio is 8 feet by 21 feet. You have to plug that back in, though, to length and width. You can't just go with the x values because those don't represent what the problem is asking for. That's something that's unique to these real-life scenarios. Yes, those 13 and negative 16 do make the equation equal 0, but they are not the length and width of the rectangle.